Okay, friends, we're starting the today's lecture. I am going to share the screen, and in last lecture, we're starting the syllabus discussion. Okay, okay, friends. In last lecture, we studied the introduction of the syllabus for unit first, and that is related with the energy. In that, we discussed the wind energy, again solar energy, again biomass energy. Today we are going to discuss the introductory information about the second unit, and second unit is the combination of the two topic, that is, one is the superconductivity and another is the nanotechnology. The both the topics, that is superconductivity as well as the nanotechnology, are very interesting, and they has a research aptitude. They can create our research view in sense of front areas of the physics, and total these two topics are related with the material science. These are related with the characteristic of the material, like that. The one another paper is the crystal structure. Here in this topic we are just studying the crystal structure in view of research. That is, both the topics are applied in nature. Just I say that these are the front areas of the physics, and this topic has big opportunity of the research. These are very interesting and applicable also. These both the topic are interesting, no doubt, but as well as they are going to create the research aptitude of the physics student, which are who are studying the material science at BSc 3. These topics are introduced in syllabus to create a research view of the physics student. या टॉपिकना मी मित्रांनो फार चांगल्या पद्धतीने न्याय देणार आहे, कारण हा टॉपिक असा आहे की म्हणजे दोन्ही टॉपिक असे आहेत की जी तुमची रिसर्च ऍप्टिट्यूड वाढवतील, रिसर्च बद्दलचं तुमचं नॉलेज वाढवतील, रिसर्च बद्दल तुमची ॲफिनिटी वाढवतील, तुमची आवड वाढवतील, आणि फिजिक्स मध्ये कसे वेगवेगळे फ्रंट एरियाज आहेत ज्याच्यामध्ये एक वेगळी रिसर्च ऍप्टिट्यूड आहे, रिसर्च करण्याचं एक मोठं फील्ड आहे. ह्या दोन टॉपिक वरून आपल्याला समजेल. आपल्याला माहिती आहे क्रिस्टल स्ट्रक्चर, बेसिकली क्रिस्टल स्ट्रक्चर, जस्ट डिफाइन द क्रिस्टल स्ट्रक्चर असा जर प्रश्न केला तर आपण सिंपल डेफिनेशन बघतो, दॅट इज द regular, identical and periodical arrangement of the atoms, molecules, or the massive motif. It is known as a crystal structure. Crystal structure is the identical, unit, periodical arrangement of atoms or molecule or the massive motif That is the group of molecule, group of atom, group of molecule and atom, maybe. But the arrangement should be identical. It is repeating in all direction, means in 3 dimension, and it is periodic also. That is, after the same period, after the same distance, the motif is repeating, and such arrangement is known as a crystal structure. And basically, the physical properties, chemical properties, again the appearance or the different chemical reaction in which that matter is to be taking part, all these process, that is the mode of properties, it may be chemical, physical, mode of reaction, in all these that matter will behave according to its crystal structure. Means that the property of the crystal, why the sugar is sweet, you know the taste of the sugar, also you know the taste of salt. Why that taste? Why that property? It is due to the crystal structure. Basically, crystal structure has an important role in the properties of that material, that crystal, that matter. Means that in physics, basically, in study, in getting some information of any matter, any crystal, its crystal structure has an important role everywhere. That is basically, if one can study in detail the crystal structure of that matter, that will be able to study and give the reduction of each and every property of that material. Means that the property of the matter, it is highly dependent on the crystal structure. Property and crystal structure are very correlated. Okay. Next, here in this unit, the first topic is the superconductivity. This word superconductivity, it is the combination of the two words. One is the super, and super is the latest, advanced. No barrier in that matter, that process. Super fast. It does not stop anywhere. That is superior. It is better than other. It is very superior. It means it will be highly beneficial than rather. It means the super. Conductivity. The conductivity is the property of the conductor. We know that there are the three materials. One is the conductor, other is the insulator, and third one is the semiconductor. Insulator is totally opposite of the conductor. Insulator is the material through which electric current does not conduct. Conductor is the material through which electric current is going on or electric current is conducting. Consider this is the insulator, this is the conductor. Insulator through which current does not conduct. Conductor through which current is conducting. It means what is the basic difference between these two? That is basically the one quantity is missing in between two. There is one differentiating property. That is, we are going to distinguish these two. This is the conductor, this is the insulator. And we are distinguishing, we are comparing, just we are keeping away from each other. One is the conductor, one is the insulator, by one of the best property, and that will be the conductivity. It will be depend upon the resistance. That is, the resistance is one of the physical quantity or the electrical quantity which is going to distinguish these two matter, who is the conductor and who is the insulator. That is the resistance. In conductor, the resistance is measurable. In insulator, conductor is not measurable, means it is infinite. Means the matter who behaving very high infinite resistance, that will be the bad conductor or the insulator. And the matter who is just behaving the resistance, but that resistance is measurable. It is not a very high, it is not a huge, it is not a infinite. In case that material is known as an conductor. The conductor who conducts the flow of electron means current. Flow of electron, that is the current. The conductor is who through which the flow of current, flow of electron is conducting from one end to other end, that will be the conductor. And the different materials like the aluminium, copper, again the ferrous, these are the conductor. Good conductor of electricity means their resistance is very less. The wood, plastic, paper, bad conductor of electricity, whose resistance is infinite, that is unmeasurable. Okay, but in between these two, that is, one is the conductor and insulator. In between these two, the one is very essential, that is the semiconductor. And semiconductor is the matter who behaving the combined property, who is neither conductor nor insulator. It does not act as an insulator as well as it does not act as the conductor. The semiconductor is behaving the property of the both, that is the insulator as well as the conductor. Means it is neither conductor nor insulator. तो insulator पण नहीं है, conductor पण नहीं है. Who can behaving the mixed property of the conductor and insulator? Such a material is known as a semiconductor. But in case of semiconductor, the voltage, the resistance, the current, that is the magnitude of the current, magnitude of the voltage, magnitude of the resistance are very responsible to convert their phase. Which phase? That is how the conductor is converted into non-conductor or bad conductor or insulator, or how the insulator is converting in conductor. And it is depend upon, it will be depend upon, that is the conversion of conductor into bad conductor or vice versa. It is depend upon the different parameters. Which are that parameter? That parameter are the physical quantities. Means that if the bad conductor is going to convert in conductor, who is responsible? Which physical quantity is responsible? Resistance is responsible. If we know that in case of bad conductor, resistance is infinity. If with any reason, by any reason, by some process, if it's infinite resistance is decreases, infinite resistance is decreases, and it come to the measurable point, its mode, its phase was changed, that bad conductor will be going to convert into conductor. Or consider there is the conductor, and if there is the conductor and its resistance is increased to unmeasurable condition, to the infinite value, then due to the parameter of the resistance, as just its resistance is increasing, and it will be increases up to infinity value, the conductor will be converted into bad conductor. And these two situations are observed in case of the semiconductor. Friends, the superconductivity, that is the name as shown name of this topic. The superconductivity is the related with the conductivity, means it will be related with the conductor. That is the property of the conductor is to conductivity, or the conduct the electric current or the flow of electron from one end to other end. That property will be known as a conductivity, and conductivity will be depend upon resistance. If the resistance is very less, if the resistance is very less, conductivity will be high. That is the inverse proportion. If the resistance is small, conductivity is the greater. If the resistivity is the greater, conductivity is the smaller. The smaller conductivity, it goes to insulator. Higher the conductivity, it goes to conductor. Okay? And who is the superconductor? Just I get the information about the conductor, insulator, semiconductor. I does not. That is the conductor and insulator, superconductor. Sorry, that is semiconductor and conductor are not applicable here. Only conductor. But not only conductor. We want here the superconductor. And superconductor has a property of the superconductivity. Superconductivity is the property of the matter if its resistivity is 0. Infinity resistivity, it comes to the insulator. 0 resistivity, that matter will be known as a superconductor. Superconductor is the conductor whose resistivity is the 0 and its conductivity is infinite. ज्याची conductivity infinite आहे, ज्याची resistivity nearer to 0 आहे, that will be known as a superconductor. And here the superconductor is the material whose resistivity is the 0, and till yet friends, till yet we does not get any type of superconductor. Friends, in last two decade, that is 20 years. In last 20 years, all the physicians of the physicist, researcher, that is the person who has a great ability in physics, they are searching the cryogenic. That is they are going to search the superconductor. ज्यावेळेला सुपरकंडक्टिव्हिटीचा उदय झाला, कामर्लिंग इन 1910 ला त्यानं पहिल्यांदा हा जो लिक्विड हेलियम नावाचा जो काही पदार्थ आहे तो पाहिला आणि तो 4.2 डिग्री केल्विनला त्यानं नेला and 4.2 degree Kelvin ला disappearance of the resistivity will be seen. Disappearance of resistivity will be seen means its resistance will be disappeared. Its resistance will be disappeared means its resistivity decreases to 0. आणि त्याला एकदम म्हणजे त्याला काही सुचेना. कामर्लिंगला लक्षात आलं का रे रेजिस्टिव्हिटी डिसअपिअर होते एखाद्या मटेरियलची. Means that matter will be acting as the superconductor at 4.2 degree Kelvin temperature, and he published his work and he get the best famous Nobel Prize in physics for the superconductivity in 1911. Friends, after this research, all the physicians in the world will be going back. They will be running in back of the superconductivity. They relying on the concept that one of the superconductor will be just we are able to search. Just we have to research the one of the superconductor who can be operated at room temperature. But in last 2 to 3 decades, जवळजवळ 30 वर्ष जगातले सगळे फिजिशियन्स, सगळे रिसर्चर, सगळे गाईड हे कुणाच्या पाठीमागे होते मित्रांनो? या सुपर कंडक्टरच्या पाठीमागे होते. कुठला तरी एक सुपर कंडक्टर, मग तो मटेरियल मध्ये मिळेल, नॉन मटेरियल मध्ये मिळेल, सिरॅमिक मध्ये मिळेल, मिक्स मध्ये मिळेल, ब्रास मध्ये मिळेल, ब्रॉन्झ मध्ये मिळेल, इन एनी मटेरियल, इन एनी फॉर्म, with any crystal structure and any composition, composite material, that is they are searching. They try to search the one of the superconductor who was going to work at a room temperature, but unfortunately all the researchers in the world are unsatisfied. They could not get the success in searching the superconductor which was working at room temperature. Friends, they are disappointed. The researchers in the world are disappointed because they do not search the superconductor who was going to work at a room temperature. It means that this opportunity, this disappointing fact will clears that, which clears that there is no any superconductor was searched till yet today. Then some of the researcher will make the comment that the superconductor is not a state of the matter, but it is the one of the phase of the matter. You know, state is the permanent residence. State, that is the stone is the solid state, water is the liquid state, oxygen is the gaseous state. That is the in gas state, oxygen, it is the permanent state. Stone, that is the solid state, is the permanent state. It means that some of the researcher will relying on the fact that Superconductivity, superconductivity, Pratiksha. Hello, Pratiksha. Yes. Superconductivity was not a state of matter, but it is the phase of matter. Means that आपण कधी तर हसतो, आपल्याला आनंद होतो. आपण कधी तर रडतो, आपल्याला दुःख होतं. आपण कधी तर रागावतो, because we are making the angry. Just I make the angry, then I will be fire. I will be behaving my angriness on my face, through my word, through my behavior, through my actions. I will be behaving my angry face. Angry face, through the face, through the words, through the behaviorness, or through the action. In happiness, I will be showing my happiness on the face. I am laughing. I am congratulating each other. I am by action. I will behaving my happiness. If I will be sad, in sad face, I will behaving my sadness. In different form, I will cry. I will does not talk with anyone. I does not in sharing with anyone because I am sad. That all behavior will be showing by each and every action. Like that. Like that. The some conductors just hear keenly, just hear properly. Some of the conductors will go to the phase of superconductivity if the two matter parameters are changed. That is, one of the conductor will be going to phase of superconductivity, but who is responsible to switching its conductivity phase to superconductivity? There are the two parameters who are responsible for switching its conductivity phase to superconductivity. One is the magnetism which was applied to that matter. The magnetic field which was applied to that matter and temperature of that matter. If I decrease the temperature of the helium from room temperature to the 0 degree Celsius and again decreased to minus 4.2 degree Kelvin. कुठेपर्यंत गेलो? रूम टेम्परेचर पासून मी त्याचं टेम्परेचर कमी 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 केलं, 0 डिग्री केलं, पुन्हा कमी केलं, 4.2 डिग्री केल्विन केलं, की the phase of the liquid helium will be converting from conductor to superconductor because it was showing the property of it will be disappearing the property of the conductivity and showing the property of the superconductivity. It means its resistance is disappeared. Its resistance who was measurable at room temperature at a temperature minus 4.2 degree Kelvin, its resistance is disappearing. Its resistance become zero. disappeared, अदृश्य झाला. मिस्टर इंडिया अदृश्य झाला. That is, its resistance is disappearing. And once its resistance is disappearing at the temperature 4.2 degree Kelvin, it will be acting as the superconductor that is losing its resistance. But that phase of superconductivity, that phase of disappearing of the resistance will be for very small time. It is not a permanent state. It is not a, that is the permanent, its appearance, but it is the very small phase that will be the superconductivity. Once that temperature 4.2 degree will be changed, it will be decreased or it will be increased. The superconductivity appearance will be disappear, and again that material will be converted into conductor. Means that for very short and for very small moment, it will be acts as the conductor, and this will be the magic, very magic, for the magical incidents. Because consider, just I make the angry for 7 into 42 hour, आठवड्यातले 7ही दिवस आणि 24ही तास मी अँग्री असतो का? काय येईल त्याला शिव्या घालायच्या, येईल त्याला बोलायचं, येईल त्याच्यावर दात खायचं, येईल त्याला काहीतरी ऍक्शन मध्ये त्याला ढुशूम करायचं. नो, नो, that is, the angry is not a permanent behavior of mind. It is not my permanent behavior. It is my phase. Happiness, also happiness is not a, also happiness is not a, yes, you are able to hear? मित्रांनो, आवाज येतोय का माझा?
येतोय सर.
Okay, thank you Prajwal, thank you. That is, the angriness or the happiness is not my permanent behavior. It's my phase. The incidence of the angriness was came, I becomes angry. The incidence of the happiness was came, I becomes happy. But what is the my normal behavior? The normal behavior is, I am softy, just I am smoothie, I am working smoothly, I will be I will be just behaving lovely. That is the permanent behavior mine. But what is my phase? The angriness and happiness is my phase, but it's for a while, it's for a moment. Like that the sum of the material will be appears at some temperature or at some magnetic field. There will phase will be changed, it will be appear like a superconductor for a very while, for very small time, and that will be the phase. Friends, till yet आतापर्यंत जगातला कोणताही शास्त्रज्ञ परमनंट सुपरकंडक्टर शोधायला काय झालेला नाहीये, की सक्सेस त्याला मिळालेला नाही, त्याला यश मिळालेलं नाहीये. आतापर्यंत मॅक्सिमम 125 डिग्री केल्विन टेम्परेचरला काही कंपोजिट, काही सिरेमिक मटेरियल, मिक्स मटेरियल हे काय होत आहे, हे सुपर कंडक्टर म्हणून ऍक्ट होत आहेत. आपल्याला 273 म्हणजे रूम टेम्परेचरला आपल्याला काय करायचंय, सुपर कंडक्टर करायचंय. सध्याची फॅब्रिकेशन टेक्नॉलॉजी मित्रांनो, सध्याची जी फॅब्रिकेशन टेक्नॉलॉजी आहे, सध्याचं जे इन्व्हेन्शन टेक्निक आहे, सध्याचे जे फिजिशियन सध्याचे जे फिजिशियन आहेत, ज्या लाईननं काम करतायत, ज्या लाईननं रिसर्च करतायत, या लाईननं गेल्या 30 वर्षामध्ये आपल्याला सुपर कंडक्टरचा काय मिळाला नाही, रूम टेम्परेचरला सुपर कंडक्टिंग फेज काम करेल असा सुपर कंडक्टर आपल्याला मिळाला नाही. याचा अर्थ तो मिळणार नाही असं नाही. There is the limitation of a fabrication technology. There is the limitation of the different parameters. If that time was came, we are getting the success to search the superconductor. The whole phase and whole nature of the electronic industry will be changed revolutionary. अरे फक्त कॅडमिनियम आणि लिथियम बॅटरी आली तर मोबाईल आणला आणि आपण कार पण आणली मित्रांनो. इलेक्ट्रा कार आणल्या, इलेक्ट्रा व्हेकल्स आणले, मोबाईल्स आणले, आपण सोलार एनर्जीचं इम्प्लिमेंटेशन आणलं. सोलार एनर्जीमुळं LICD, कॅडमिनियम आणि लिथियम बॅटरी स्टोअर केली. आज महिन्यातून एकदा चार्ज करायला लागणारी बॅटरी आपण आणतोय. दॅट इज इट्स स्ट्रेंथ विल बी इन्क्रीज. अँड इफ द सुपर कंडक्टर, जर तो सुपर कंडक्टर भविष्यामध्ये मिळाला तर जगामध्ये इलेक्ट्रॉनिक्स मध्ये क्रांती होईल. कम्प्युटर्स पुन्हा एका चिपवर येतील. कम्प्युटर कुठेही आपल्या शरीराच्या अवयवाच्या कुठल्याही भागावर आपल्याला फिक्स करता येतील. मेडिकल सायन्स प्रचंड डेव्हलप होईल. माणसं आजारीच पडणार नाहीत किंवा मृत्यूचा समय माणसांचा पुन्हा वाढेल. शिप हे स्लाइस वरती काम करेल. मित्रांनो, मॅग्नेटिझम साधं उदाहरण घेतो. जर आपण सुपर कंडक्टिव्हिटी आणली आणि सुपर कंडक्टर जर मिळाला तर आपल्याला माहित आहे, कॉपर जर आपण मॅग्नेटाइज केला, त्याच्यावरनं मॅग्नेट बऱ्याच वेळा फिरवला तर तो परमनंट मॅग्नेट होतो की नाही. पण मित्रांनो, वन्स इलेक्ट्रोमॅग्नेट जो आहे, इलेक्ट्रोमॅग्नेट हा जर सुपर कंडक्टरचा तयार केला, एकदा त्याला मी इलेक्ट्रिसिटी दिली आणि बंद केली की तो परमनंटली इलेक्ट्रोमॅग्नेट म्हणून ऍक्ट होतो. काय होईल जगाचं? सप्लायच लागणार नाही, कारण रेजिस्टन्स 0 झाला. अरे कोयनेपासून वारणेपर्यंत जर मला इलेक्ट्रिसिटी आणायची असेल तर किती तर तिथं आपल्याला MSEBचे कार्यालय, MSEBचे बूथ दिसतात, ज्याला आपण MSEBचं जिथं आपण HT एरिया दिसतो आपल्याला, हाय टेन्शन एरिया, ज्याच्यामध्ये त्याचं व्होल्टेज वाढवायचं काम केलं जातं. का तर कंडक्टर मधून जाताना रोध असतो, म्हणजे रेजिस्टन्स असतो, त्यामुळं अनेकदा एनर्जी खर्ची पडते आणि पुन्हा ट्रान्सफॉर्मर, म्हणजे हे सगळेच्या सगळे ट्रान्सफॉर्मर हे स्टेप अप ट्रान्सफॉर्मर असतात आणि स्टेप अप ट्रान्सफॉर्मर आपण यूज करतो आणि पुन्हा त्याचं काय करतो आपण मित्रांनो, स्टेपिंग अप करतो आणि पुढे चालवतो. पण जर आपल्याला सुपर कंडक्टर मिळाला 1000 व्होल्ट जर कुठं असेल, कोयनेत असेल, तर वारणेत जर मेजर केलं तर 1000च असेल. आपल्याला स्टेपिंग अप करायची गरज नाही मित्रांनो. कितीतरी मोठं काम जे आपलं कमी होईल if we get the superconductor. And such a interesting area of material science is inserted here by the superconductivity chapter. Just see what are the syllabus of the superconductor. This is the syllabus of the superconductivity, idea of superconductivity, critical temperature where the any conductor will be acts as the superconductor. Just I tell that here the helium, liquid helium will be just acting as the superconductor at 4.2 degree Kelvin. That temperature is known as an critical temperature. Critical magnetism म्हणजे magnetic field in which that in which that material is to be inserted, that will be known as an critical field. And critical field is also the magnetic field where the any one conductor will be acting as the superconductor. The Meissner effect is very, very important effect. Meissner is the name of the scientist, and we search the effect where the that is the unmagnetism or disappearing of the magnetism, that will be the behavior. It will be shown by the Meissner, and according to Meissner effect, he will be gives the two types of the superconductor, that is the type first superconductor and type second superconductor. Type first superconductor who strictly follows the Meissner effect. म्हणजे जे पदार्थ, जे मॅटर सुपरकंडक्टर किंवा मेझनर इफेक्ट स्ट्रिक्टली फॉलो करतात त्यांना आपण काय म्हणतोय, टाईप फर्स्ट सुपरकंडक्टर म्हणतोय. इन टाईप सेकंड सुपरकंडक्टर मेझनर इफेक्ट इज नॉट स्ट्रिक्टली फॉलोड. म्हणजे कसं आहे, द पर्सन हू स्ट्रिक्टली फॉलोज द रूल इन कॉलेज, that student will be known as an ideal student. There are some student who strictly follows the rule. That is, sir, just invite the link. Sir, send the link on WhatsApp group at morning, and the last message of the sir is the please join on a time. Sir is repeatedly giving the message of the please join in time, please join in time. What is the strength of the class? Strength of the class is about the 40. What is the joining strength? It is about the 12 or the 13. It is about, it will be less than 30%. That is, students are following the rules. What is the answer? Yes, low, yes, no, moderately. Here I will give the answer of the moderately. Kai students, some of them, some extent of them will going to strictly follow the rules. What about the other? They did not strictly follow the rules. This says that rules are not for us. Just we are making the rules. We are implementing the rules. That will be, there are the two behavior, two groups. There will be distinguishing property of strictly obeying the rule, strictly disobeying the rule. Who strictly obeying the rule, that is, they follows the Meissner effect, that will be known as a type first superconductor. Who disobeying the rule, who does not strictly following the Meissner's law, Meissner's effect. That will be the type second. It means that. It means that type first is essentially important and applicable superconductor for the superconductivity application rather than the type second. And here also, type first is known as an soft superconductor. Type second will be known as an hard conductor because their subject is become hard विषय आहे म्हणतोय बघा आपण. That will be their subject. That is the consciousness गांभीर्यता, and it becomes high, it becomes deep. That will be known as an hard superconductor. Friends, इथं type first superconductor, type second superconductor, then Landon equation for the penetration depth. Very nice, interesting property of the penetration of the depth. Penetration, that is magnetism. If I place the one of the material inside the magnet, magnetization or the magnetic field is penetrating through it. That matter is the magnetized. Hypnotism, समजा एखादा हेप्नॉटिझम एक्सपर्ट आहे आणि एखाद्याला हेप्नॉटिझम केलं तर हेप्नॉटिझम काय सुपरफिशियल असतं का? सुपरफिशियल असतं का? नो, इट विल बी इनर्टली, आतून असतं, आतून. And such a type of magnetization, that is penetrating depth, it will be appeared in case of superconductor. And again the isotope effect application, there are the different and huge list of the application of the superconductor. There are the number of application of the superconductor in research area, in the social area, in educational area, in industrial area, in all where there are the different application of the superconductor. Friends, here we explain the superconductivity. In next lecture I will going to explain the nanotechnology. If anyone has any doubt about the concept of the superconductivity, application of the superconductivity, behavior of the superconductivity, characteristic of the superconductivity, work of the Meissnerचं जे वर्क आहे त्याच्यावरती कोणाला काही प्रॉब्लेम असतील तर विचारा. Meanwhile, before going to session is open for the discussion. Before it, please submit your attendance in chat box. Last attendance in chat box. काही शंका असेल तर विचारा. बरेच जण लेट जॉईन झालेले आहेत. आपण परवा ठरवलंय 8 वाजता पहिलं लेक्चर होणार, तरी आपण 8:05, 8:10 सुरू करतो. उरलेल्या मित्रांना आपल्या कल्पना द्या. हा डिजिटल अटेंडन्स आहे. कदाचित तुमची पुढची परीक्षा होईल नाही होईल. जर झाली नाही तर अटेंडन्स वर मार्क्स द्यायचा राईट हा माझ्या हातात आहे, हे लक्षात घ्या. मी काही टेस्ट सुरू करणार आहे. कारण का तर काय परिस्थिती होईल आपण बघतोय. वर्षापेक्षा जास्त काळ गेलेला आहे मित्रांनो. खरं म्हणजे मी BSc फर्स्ट आणि BSc सेकंड आणि BSc थर्डच्या सुद्धा टेस्ट घेऊन ठेवल्या होत्या मध्यंतरी. तुम्हाला माहित आहे मी एक दिवस कशासाठी घेऊन ठेवल्या होत्या की काय परिस्थिती होईल सांगता येत नव्हतं. पेशंटची संख्या या पॅडेमिक सिच्युएशन मध्ये वाढत होती आणि त्यामुळेच आपण त्या गोष्टी केल्या होत्या. कदाचित विद्यापीठानं पुन्हा सांगितलं त्यांची सेकंड सेमिस्टर घ्यायची की नाही. हा काळ किती काळ लांबतोय त्याच्यावरती मित्रांनो पुढचा भाग आहे. त्यामुळं थोडंसं अलर्ट राहा. फारच इझी घेऊ नका. जगात स्वस्त आणि सहज असं काहीही नसतं. प्रत्येक गोष्टीच्या मागं हार्डवर्किंग इफर्ट्स गरजेचे असतात. मग ती गोष्ट छोटी असू दे किंवा मोठी असू दे. मित्रांनो, आम्ही बऱ्याचदा फिजिक्स शिकवत नसतो, जगणं पण शिकवत असतो. फिजिक्स काय आपण पुस्तक वाचून सुद्धा, सुपर वाचून सुद्धा, परीक्षेमध्ये काहीतरी इकडचं तिकडचं करून सुद्धा फिजिक्समध्ये डिग्री घ्याल. पण फिजिक्सचा वापर आपल्या लाईफमध्ये करून आपलं लाईफ कसं एन्जॉयमेंटमध्ये करायचं, लाईफ कसं स्मार्ट करायचं आपलं, त्यासाठी मित्रांनो थोडंसं वर्गात येऊन बसावं लागेल. वर्गात येऊन सरांचं वेगवेगळे ऐकावे लागेल. वेगवेगळ्या सरांचे लाईफकडे बघण्याचे, करिअरकडे बघण्याचे काय व्ह्यूज आहेत, काय दृष्टिकोन आहेत, हे थोडंसं बघावं लागेल तुम्हाला. आणि हे बघितल्यामुळं तुमचा दृष्टिकोन क्रिएट होईल. आपोआप होत नाही मित्रांनो, झोपा काढून आपला दृष्टिकोन काय क्रिएट होत नाही. म्हणजे बरेच जण, आता माझे स्टुडंट जवळजवळ अजून एक 20 ते 30 स्टुडंट, मिनिमम 30 स्टुडंट मित्रांनो काय करत नाहीत, येत नाहीत लेक्चरला. नेमकं काय आहे? कारण त्यांना माहिती आहे की परीक्षा एवढी इझिएस्ट झालेली आहे. मी कसंही बसलो, धड्याच्या खालचं जरी बघितलं, ऑनलाईन असलं आणि ऑनलाईन जरी परीक्षा असली, मी ओपन बुक ठेवून बसलो, 4 मित्रांना एकत्र केलं आणि त्यांना मी प्रश्न दिले 5-5-5, तरी सुद्धा मला काय होतंय, पास होऊ शकतोय मित्रांनो. दिस इज द फेज. जस्ट आय स्टडीड यू. दिस इज द फेज. पोट भरल्यासारखं वाटेल, पोट भरलंय असं वाटेल, पण पुन्हा एकदा जेवायची गरज पडेल. तसं आनंद हा, तुमचा जो आनंद आहे तो व्हेरी टेम्पररी आहे. बिकॉज युअर करिअर विल बी डिपेंड ऑन युअर नॉलेज. भविष्यातलं जे तुमचं करिअर आहे हे तुमच्या मार्कावर अवलंबून नाही आहे, तुमच्या नॉलेजवर अवलंबून आहे. आमच्याकडे एक म्हण आहे, म्हणजे आम्ही ज्यावेळेला BEdला होतो, MEdला होतो, त्यावेळेला आमचे प्रत्येक सर आम्हाला सांगायचे, बुद्धिमान माणूस हा चांगला शिक्षक असतो असं नाही. बिकॉज टीचिंग इज द बेस्ट स्किल. टीचिंग लर्निंग इज द स्किल ओरिएंटेड प्रोग्राम. ज्याला कौशल्य असतं तोच आदर्श शिक्षक होऊ शकतो. आपल्याला आदर्श माणूस, आदर्श वडील, आदर्श भाऊ, आदर्श मुलगा, हे जे वेगळे वेगळे रोल आहेत आपले सोसायटीतले आणि फॅमिलीमधले, ते रोल जर आपल्याला प्ले करायचे असतील, अगदी सक्सेसफुली प्ले करायचे असतील, तर यू रिक्वायर द इंटेलिजन्स, you require the skills, you require the knowledge, and we require the confirmation of knowledge. And for that you have to attend the online class or the classroom work. It may be because in that work, in that just wait for 1 minute. हॅलो, गुड मॉर्निंग सर. हा बोला सर. हा नाही, ते जाऊन आले, ते जाऊन पण आले तिथून. बरंचसं डिस्कशन झालं काय. मी आता एक 5 मिनिटात फोन करून घेतो, मी लेक्चरवरनं बाहेर पडलो. हा बर बर. हा हा हा. अच्छा. बर 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 बर. नाही, राहू दे की, राहू दे, राहू दे. हा हा. बरोबर. येस सर. ओके. बरं हे हे फायनल आपण झालं का आपलं हे टाकलं का फायनल? ओके ओके. त्यांना टाकलं का कॉलेजला? ओके ओके. तेवढं करा, मग मी त्यांच्याशी बोलून घेतो लगेच. मी ऑनलाईन लेक्चर माझं आता आहे लेक्चरमध्येच, पण तुमचा फोन असल्यामुळे मी रिसिव्ह असू दे, काही हरकत नाहीये. मी यातनं रिकामा झाला की मी घेतो. येस सर, येस सर. थँक्यू. ओके, गुड डे. ओके. तर मित्रांनो, म्हणजे काय आहे की बऱ्याचदा आपल्याला असं वाटतंय की क्लासमध्ये येणं, ऑनलाईन क्लासमध्ये जाणं काय फारसं प्रॉफिटेबल नाही आहे. पण मित्रांनो, यामध्ये वेगळे वेगळे व्ह्यूज मिळू शकतात. कदाचित तुमच्या करिअरला कुठेतरी कलाटणी मिळू शकते. अशी काही गोष्ट येऊ शकते. कदाचित ती गोष्ट तुमच्या परीक्षेच्या दृष्टीनं तुम्हाला आज मितीस उपयोगात वाटत नाहीये, कारण नेचर ऑफ एक्झामिनेशन बदललंय म्हणून. हे लक्षात घ्या. पण इट्स व्हेरी इम्पॉर्टंट. आपल्या सगळ्या मित्रांना सांगा की सरांनी अगदी फारच वेगळ्या पद्धतीनं तुम्हाला लेक्चरला यायला सांगितले, लेक्चरला अटेंड व्हायला सांगितले. दिवसातून 1 तासच आहे आपण मित्रांनो, 1 ते 1.5 तास आहे. एवढाच वेळ आपण ऑनलाईन यायचं आहे. बाकीच्या गोष्टी आपल्या ज्या आहेत त्या आपण सुरू ठेवायच्या आहेत. त्याच्यामधून नवीन काहीतरी ओपनिंग्स तुम्हाला मिळत जातील, निश्चितपणे मिळतील. ओके. काही अडचण आहे का सांगा? प्रतीक्षा, प्रज्वल, पूनम. चला बोला कोणतरी. साक्षी, काय अडचण आहे?
नाही सर. नाही सर.
ओके ओके. अभ्यास चालला असेल तुमचा, थांबूया आपण. ओके. जरा परत एक दोघा चौघांनी शेवटचा एक अटेंडन्स द्या, म्हणजे मला टायमिंग कळत असतं. परत एकदा अटेंडन्स द्या दोघा चौघांनी. ग्रुप वरती कोणीतरी कॉमेंट टाकत चला. नाईस लेक्चर, नाईस इन्फॉर्मेशन. वी गेट lot of information about the superconductivity. Superconductivity is the one of the best research area. अरे काहीतरी कॉमेंट टाकत चला, म्हणजे मला तुम्ही तुमच्यातलं फिजिक्स जिवंत आहे असं मला दिसेल. त्या सोडून वेळ कोणासाठी थांबणार नाहीये. पण मी थोडंसं तुमच्यामध्ये फिजिक्स जिवंत करू शकलो की नाही एवढं तरी मला कळेल. ओके. Okay, friends, we are leaving the meeting. Thank you. Have a nice day and just take care in this pandemic situation. Thank you. Okay.